Hello everyone, and welcome back to the Kohi Game Engine series. Today we are going to tackle the font system as well as something that we're going to call UIText. So let me get into code. So there are a couple things that we're going to need to put into place. In the last video, we went ahead and stood up our bitmap font loader, and we went ahead and registered it so it's all ready to be used. And in this video, we need a way to actually use that. Now, we could create some sort of bitmap text object. We could create some sort of system text object once we create our system font and get that loaded in. But we're going to be dealing with these two different types of fonts. And even though that we only have one of those implemented right now, I want to go ahead and create the system that is going to utilize both of them or allow both of them to be used. And I've done a lot of thinking about this, whether we have different text objects that are used to actually display text using the fonts for each type of font, or whether we have one that's capable of handling either one, whether we have different systems for the different types of fonts, or whether we have a single system. And in both cases, I've elected to have a single thing for both types. So we're going to have a font system that manages our bitmap fonts as well as our system fonts once we get those in place. And then we're going to have a UIText object, which is basically responsible for rendering text using a font of a given type. And that's also going to handle both types of fonts. And so both of these things are going to be developed in such a way where they work generically with both, so that we have as much logic reuse as possible with very little, repetitive code, if any at all. So with all that said, let's go ahead and dive into it. So the first thing that I'm going to start with is I'm actually going to start with the font system itself, because I think having the font system in place makes the most sense for us to be able to actually start using it, using fonts, right? And then we'll go on to the actual rendering of it. So under systems, I'm going to create a new file. We're going to call this font system.h. And we're going to start off, obviously, by including some header files. So our renderer types and our math types, we're going to need both of those things. But we're also going to go ahead and define a couple of structures that we're going to need. So in there, we're going to have a, a font system config. And this, a system font config. Dyslexia strikes again. System font config is basically going to be the configuration for a system font. Now, we do not have a system font in place yet, but I wanted to go ahead and stand this structure up because we are going to have one here shortly. And then we have a bitmap font config. So the main difference between these is we have, for the system font config, we have a default size, because a single system font isn't limited to a single size. We can have multiple sizes for that. But if we just want to create a default size for that, we can go ahead and declare that. For the bitmap font, it's a little bit different. So in that case, we do have a name and then a size. So bitmap fonts can only have a single size. So that is the primary difference between the two. And then, of course, both have a resource name as well. Next, we have the font system config, which is not to be confused with system font config. So this is for the font system itself. So we have in here the default system font count, and then an array of those system font configs, and then a default bitmap font count, and an array of those bitmap font configs. So these two things are configurations for the fonts that will be loaded by default. Now, of course, at any given time, we'll be able to load up additional fonts into the system. These are just ones that are sort of loaded up when the engine is stood up initially, just to kind of give us some base fonts that'll be available for use throughout the system. So we're going to set up some of those. We also are going to provide a max system and max bitmap font count. So those will be the maximum that the system can actually hold. That just helps us kind of get an idea of how much memory we need to actually allocate. Of course, since this is configuration, this will eventually be tied to a configuration file, so that will be changeable without having to modify code, but that's a little bit further down the road. The other thing that we have in here is whether or not we want to auto-release fonts. And what that means is basically whenever we are done with a font and we're no longer using that font, whether or not we actually want to auto-release fonts or not. And so we can turn this on or off. For now, I'm probably going to leave that off just so that we're not releasing those resources for our default fonts, at least right away. There is a good chance that this auto-release is probably going to eventually wind up being moved to the font configs themselves, because that should probably be a font-specific setting, but for now, I'm just going to leave it here. Okay, so the next thing that we need to do is we need to forward declare a structure called UIText. And this is going to be the structure that is going to represent a drawable text sort of object, if you will, that contains the text representation in memory, but also has a reference to a font and is responsible for generating the geometry with the appropriate positions, texture coordinates, things of that nature. And that will we'll also be declaring that here shortly, but we are going to be using pointers to that, so I do need to forward declare that here. So the next thing is, just like for any other system that we have a font system initialize, which takes our memory requirement, memory, and a pointer to some config, and then of course the shutdown, which again takes a pointer to a block of memory. So this is the same stuff that we have seen time and time again with our various systems. So the meat and potatoes of this system are going to be next. So we have load system font and load bitmap font. These are pretty obvious in what they do. You pass it a config, it loads up a font, and that font is then ready to use. Next, we have a acquire. So the acquire basically is going to have you provide a font name and a font size, and then a UIText to acquire the font instance for. So we'll have a sort of internally running counter, reference counter for each individual font that'll be incremented or decremented, whether we acquire a font or we subsequently release a font. So obviously that means we need a font system release. And then there is one more thing that we need. Oops, let me actually get rid of this terminal. It's kind of in the way. Which is going to be font system verify atlas. And basically what this is going to do is it's going to verify that our texture atlas supports all of the characters that are in a given string of text, and it will return appropriately. Now, I do want to point out that that will not happen for bitmap fonts. However, we want to provide the interface regardless, so that all fonts are sort of treated equally. So all we have to do here is provide the font and the text to verify against. So bitmap fonts, since they can't generate text on the, or not text, glyphs, they can't generate sort of glyphs on the fly. They will not be using this, but again, it's there for when we need it for system fonts. So that is the entirety of the interface for our font system, right? It's not overly complex, at least on the surface. And the back end of this is actually not too terrible either in terms of how much code we need to actually go through and write. So with that said, we're going to go ahead and create the C file. Font system.c. And we are going to include a bunch of stuff that we are going to need. So we're obviously going to include font system, kmemory, logger, kstring, darray, hash table, resource types, UIText, which I understand we have not created that yet, but we are actually going to need it. and then the renderer front end H, the texture system H, and the resource system H. So before we actually jump into the implementation of the font system, I do want to go ahead and create this UIText file because we are going to need that at least to be able to write some of the functions in here. So what I'm going to do is that is going to live under resources. So I'm going to go up here under resources, create a new file, and I'm going to call it UIText.h. And we're just going to set up sort of the public interface for this right now. So obviously we have our pragma once. We're going to use math types, resource types, and renderer types. We are going to forward declare a structure called font data that we use in the font system backend. And that's because some of our methods actually take pointers to that, but we don't need to know about the underlying type at this level. So the next thing is we're going to have a UI text type, which is also bitmap and system. I would like to eventually eliminate these, but at least for right now, they are actually going to be needed in the font system query. So when we are actually standing up a font, we are going to have to be aware of, are we using a bitmap font or are we using a system font? And I think that's perfectly acceptable because you're generally going to need to know the source of what that font comes from. So that's what we're going to go with for now. Our UI text structure is next. And so this basically stores that type. It stores the data of the font that it is associated with, so it maintains a pointer to that. It has two render buffers, so a vertex buffer and an index buffer. It has a character array to hold the text. It has a transform so that it can actually be moved around on the screen. It has a instance ID and a renderer frame number. So those are used for synchronization with the renderer internally, but that's what those things are used for. So we only have a few actual methods here, so I'm actually going to paste all these at once. And so we have a create and destroy, which are pretty self-explanatory, I think. The text create takes a type, the name of the font we want to use, the font size, which is really irrelevant for bitmap fonts, but it's still, we're going to wind up using it anyway. And then we have the text content to create it with, and then a pointer to hold the created UI text object. Obviously, we have a destroy, which takes a pointer to a text object. All these take a pointer to a text object, in fact. And then we actually have a utility method to set the position of a UI text. And this should be used as opposed to setting the transform directly here, because there's some internal stuff that we really should go ahead and do. And then there's also set text, which also should be used in favor of just setting this directly, because we have to regenerate some things internally. And then we have this UI draw text, which is actually, this should just say text, not bitmap text. In fact, I'll follow the convention here that I have for UText. And so this simply just draws the given UI text. So, and that is all there is to the UI text, at least from an interface perspective. So now that we have that, we can go back here into our font system.c, and for some reason it's still actually bleating about that not existing. So let me try closing the file, reopen it. VS Code gets a little bit weird about that sometimes. Okay. So our font system.c file, like I said, there's not that much code in here for that, but you know, there's I wouldn't call it a trivial amount either. It's a couple hundred lines at least. So now that we have our includes, we are going to need to define several structures. So the first thing that we're going to do is we are going to define a bitmap font internal data structure. And this is going to keep the resource itself. So when we load up a new bitmap font, that's where the resource is actually going to be stored. And then we are going to basically hold a casted pointer of the resource data. And that's purely for convenience. So this will basically be this object.data, and then we'll save a pointer to that here, just so that we don't have to cast it every single time. We're also going to have a bitmap font lookup. This will be used in conjunction with a hash table. where each individual font that we add will have an internal ID, a reference count, as well as the bitmap font internal data itself, which is this structure here. The next thing that we're going to have is the font system state, which is the overall state for the system itself, which will hold a copy of the configuration, a hash table for the bitmap font lookup, an array for the bitmap fonts themselves, and then a block of memory for the hash table itself for its internal data. And so eventually we'll wind up having another hash table for system fonts and things like that because they need to be held separately. And so this is how we're going to manage that, at least for right now, is everything's going to be in that state object. Next, we're going to forward declare a couple of internal methods. So we're going to have one method that is setup font data, and then another one that is cleanup font data. I'm sure you can probably surmise what those are going to do, and we'll cover those when we go into actually writing them. Next, we'll create our static internal pointer for our state. And now we can actually jump into creating the system itself. So the first thing, of course, is going to be our initialize. Excuse me. And so our initialize is actually just going to start off by doing our typical sanity checking, which checks to make sure that we're actually going to have some max system bitmap font counts. If either one of those are 0, that's kind of stupid, and it's going to basically club you over the head for that. So we don't want to do that. The next thing that we do is we go ahead and we figure out the requirements for the memory. So we get the struct requirement for the system state itself for the overall struct, the array requirement for the lookups, times the max font count, and then the hash table requirement, which is the size of a U16. That's going to be the size of our ID, times the max bitmap font count. And then we're just going to basically add all that together to get our memory requirement. And then, of course, just like the other systems that we've done, if we don't pass memory long, that means that we are only getting the memory requirement, and at that point, we should go ahead and return true. At that point, we'll go ahead and allocate some memory externally, and then call this again, at which point memory will be passed along. And we can go ahead and save off our state pointer, save a copy of our config, and then we can go ahead and set up our, let me see. So we actually just need to add this. So we have our bitmap array block. So that's basically going to be the base of the memory, and then pass the actual struct itself is where that's going to be. And then we are going to go ahead and set the state pointer bitmap fonts to the bitmap array block, just so that we have a copy of that. And then we'll say the hash table blocks come after the array. So this is actually, I don't know why that's saying that. That should be after the bitmap array block. So we have that. And then we have the hash table create, where we go ahead and stand up the hash table itself. All this is pretty standard stuff, I think. It's all stuff that we've seen before. And so I'm not really going to go into too much of this in depth. So we basically fill the hash table with the invalid ID here, and then we actually go through all of the array entries, and we fill those out with invalid IDs and zero out the reference counters for all those. And so the next thing that we need to do is we need to load up any of our default fonts that were provided in our configuration. This is sort of the last step here. So we basically loop through the bitmap fonts for now. We're going to completely ignore the system fonts because we don't have any way to load those up. But here is where we call our font system load bitmap font, passing in the configuration object that we have created in the array. And if for some reason that fails, we bleat about it and move on. We could theoretically kill the entire system if one of these fails, but that seems kind of dumb. So I'm not going to do that. I'm just going to bleat about it and continue trying to load other bitmap fonts. So once that's all done, we can return true and we are good to go. The font system shutdown is actually really simple. So I'm just going to slam that in here all at once. And basically we just clean up the bitmap fonts one by going through each one, invalidating the ID, and then going through and obtaining a pointer to the data, calling our cleanup font data, which again we'll have to go into here in a few minutes, and then invalidating the ID. And then we'll go through and we will put in the stub for the next method, which in this case is going to be to load our system font. And that, for right now, is actually just going to throw an error saying system fonts are not yet supported. But we need to at least have this here because the public interface actually requires it. So the next thing that we're going to do is we're going to set up our load bitmap font. And this is where we're actually going to do the work for bitmap fonts directly. So the first thing that we're going to do is we are going to do a little bit of sanity checking to make sure that a font with a name doesn't already exist. So we're going to check the configuration name. We are going to query the hash table to say, hey, are we going to, do we have an ID, or a font rather, that matches the config name and give me the ID? If this comes back as anything other than invalid, then that means we do not, or that means that we do rather have a font already named that. So if the ID is not equal to invalid ID, then that means we're trying to load a font twice, and we should slap the user for that. Otherwise, we will go ahead and obtain a new ID. So that's basically just traversing the array, finding the first entry that is invalid ID, and using that index as the ID. And then we're just going to do a sanity check here to say, hey, did we get all the way to the end of the array and have no slots left open? If that is the case, we're going to go ahead and spit out an error about that. And then this should be a new bitmap font. Yeah, and then we'll check that to make sure that we actually did get a valid ID for that. So the next thing that we're going to do is we're going to obtain a pointer to the lookup. So this is done just by getting the state pointer bitmap fonts sub ID, and we grab the address of that to give us a pointer to it. And what we're going to do is we're going to go ahead and call the resource system load. And we are going to call or pass the resource name, resource type of bitmap font, and then the params here are 0 because we don't really have any parameters for this type of resource. And then we're going to pass the address of the lookup that we have here, font.loaded resource. So we're going to pass the address of that so its loaded resource gets populated with the resource that is loaded from here. If for some reason that fails, we are going to bleat about it and return false. Otherwise, we are going to go ahead and keep a casted pointer to the newly loaded resource data for convenience. So we are going to set lookup, the lookup font.resource data is going to be just a cold cast of the lookup font resource, loaded resource.data rather. So that's what I was talking about all the way up here at the top, how we have the loaded resource, and then we have a pointer here for convenience. That's what I was talking about. So the next thing that we're going to do is we are going to look at the configured Atlas texture. So we're going to take a look at the first page. And note that I've got something in here that says this only accounts for one page at the moment. So this is where I was talking about the bitmap font that can have multiple pages. You're only actually going to get one loaded here. Now we could do a little bit more analyzing and load multiples of these textures, but there's some extra work that's also going to go into having to make sure that the right texture is bound for the right character, and that gets kind of messy and non-performant. So it's way better for us to have everything in one texture. So we are going to load up that texture. We are going to acquire it with auto release on true. And so whenever we release this texture, it should probably be the only thing that's actually holding reference to that texture. And so it should unload. So we're going to go ahead and set the lookup font resource data.data atlas texture to the result of that. Now, I suppose I don't actually, let's see, so resource data, yeah, okay, so that is that. So the next thing that we're going to do is we are going to call our setup font data, passing through our resource data object, and we're going to store the result of that. Now the next thing that we'll do is we will go ahead and keep that entry in our hash table. So we're going to call hash table set, passing the table the name of the font, which is in the configuration, and then the value is actually just going to be the ID that we obtained before, because that's all the hash table actually stores. So we go ahead and we set the hash table entry there. Then we go ahead and on the lookup that we obtained up here, we set its ID to match the ID, so that's permanently stored. And then we can return the result. And we're done. That is all that goes into acquiring or loading, I should say, a bitmap font, right? So it kind of follows the same pattern as a lot of other stuff we've seen within the system. All right, so the very next thing that we're going to do is, next thing in line is we've got these two set up. We have our font system acquire. And so that is going to be the next thing that we set up here. All right. And that takes the font name, font size, and text. So the very first thing that we're going to do is we are going to check to see if the text type, in other words, the UI text that we are passing in, what type is it? Is its type UI type bitmap? UI text type bitmap, rather. Or is it going to be system, right? Or, since these are really the only two other options, I suppose I could check in something else here. I'll put an else statement here as well. And I'll say k error unrecognized bitmap, font type. And then I guess I'll just text type, just in case we add another type, I guess, in the future or something. So we'll go ahead and return false here, right? We'll be explicit about it. So if we have a system font, for right now, we are actually going to error out on that as well. And we're going to say system fonts are not yet supported. So that means that really all we need to do is we need to go ahead and, in fact, you know what? I don't need this in an else block because we will just fall through to that, right? So here we'll go ahead and return true at the bottom. This one will return false because it's not yet supported, and then if it's something else, we'll go ahead and just fall through and return down there. So that's a little bit cleaner, I think. All right, so the next thing that we're going to do is we are going to go ahead and attempt to acquire the ID out of the hash table. So we're going to look that up by the font name. So that's the very first thing we obviously have to do. So we'll start off with an ID, invalid ID. We'll do the same thing as before. We'll get the hash table. If for some reason that fails, we'll bleat about it. If the ID comes back as invalid this time, then that means that the font was not found, and that the font acquisition fails and we return false. If we have found it, then we can go ahead and perform a lookup. So that lookup is basically just looking at our state pointer, bitmap fonts sub ID, grabbing the address of that, and now we have a lookup pointer. And so all we're going to do here is we are simply going to assign the data and increment the reference. So we're going to set text data to the address of lookup font resource data. And then we are going to say lookup reference count ++. And we're going to go ahead and return true. And that is all there is to acquiring a font, right? It really is just a simple lookup like this. So that is the acquire. So the next thing is obviously going to be released. So the release, I'm actually going to throw to-do in here for right now because we're not going to be releasing fonts right away. And so it's not something I need to put into place right now to actually get this up and running. But basically, we would essentially just undo this and then potentially auto release. Since I haven't really decided on how I want auto release to work yet, I'm going to leave this as a to-do item, and we can come back to it later. So the next piece of this is obviously going to be that last public function that we have, which is verify atlas. So this function is actually pretty small because it doesn't really do anything for bitmap fonts. So all this does is say, hey, if the font type is bitmap, bitmaps don't need verification since they're already generated and can't be changed. So we're going to go ahead and return true and say, hey, this supports it, right? Otherwise, we're going to say unknown font type, right? So we're not supporting system fonts just yet. So if we pass that, we're going to get an error at this point and return false. And that is it for the public-facing members. Now, the real sort of meat and potatoes in this is going to be the setup of our font data. So we're now into sort of our private functions. So we're going to go ahead and implement those. So the setup font data is basically where we are going to create the various resources that we need to be able to actually render a font. So in this case, we're going to start off by creating the texture map resources. So our font atlas, we're going to set the filter magnify and the filter minify to filter mode of linear. And then we're going to set the repeat U, V, and W to clamp to edge. Because we want clamp to edge simply because that's going to give us the clearest rendering of text given the way that we're going to render it. Next, we're going to set the atlas use to diffuse because it is a diffuse map. And then we're going to call renderer texture map acquire resources, passing that. We're going to let it do its internal things on the Vulkan backend. And then obviously, if that fails for some reason, we're going to bleat about it and return false. Otherwise, we're going to continue on. So that is our texture map. And now what we're going to do is we're going to handle the tab glyph. Now, tabs are not something that is included in all bitmap fonts, and even if it is, sometimes it's literally included with a width of 0, which is completely useless. So the rules that we're going to use is we're going to first off take a look and see if the tab X advance has been set. Most likely, probably not. Then we're going to look through all the glyphs and see if we find any glyphs with a code point of \T, which is the font escape code. If we do, we're going to go ahead and use that. If we do not actually find that, then we're going to go ahead and use a tab X advance that's basically 4 spaces, which is pretty standard in text editors, especially for monospace. You've got 4 spaces here equals a tab. So that's what we're going to stick with, at least in our system. And so the way that we're going to do that is we are going to search through for a space. And we even have a backup for that, where if we do not actually have a space glyph for some reason, which we always definitely should, but we do have a fallback. If it's still not there, then basically what we're going to do is we're going to set the tab X advance to the font size times 4, which will never be 0. So at least one way or another, we are going to wind up having a tab X advance. And that is what this does. Right? It looks like a lot of code. It looks complicated, but if you actually read it, it's not. So everything that it does is right here, right like I just explained, where we have we check for a tab glyph. If it's there, we use it. If not, we try spaces times 4. If there's no spaces, then we go ahead and use font size times 4. Okay? And that is all of the setup that's really required. So we're going to go ahead and return true here at the very end. And that is our setup font data, right? Not difficult at all. Our cleanup font data is going to be even simpler. So all this does is releases the texture map resources. If it's a bitmap font, then we release the reference to the texture. So we say texture system release, and we go ahead and 0 out the texture. And that's it, right? System fonts will wind up being a little bit more complicated than that, but not much. And that is our font system. So our font system is in, programmed, and ready to go. So the next thing that we're going to do is we are actually going to handle the rendering of fonts. And this can be a little bit long-winded, but it shouldn't be as quite as long as the last video. So what we're going to do is come up here to resources. We are going to create a new file, call it UIText.c. And the first thing that we're going to do is put in all of our includes. Okay, so we're going to need logger, memory, kstring, kmath, transform, renderer types, renderer front end, font system, and shader system. So all these things should kind of make sense given what we're actually doing here. So the next thing that we're going to do is we're going to forward declare one method, which is regenerate geometry. And that's going to take a pointer to a UIText object. And what that is going to do is it's basically going to generate all the quads that we need for the given string, given all the glyphs that are available for that font, and apply all the texture coordinates based off of all the font information that we've loaded, so that each individual quad displays the correct letter as it should in space, and all of that geometry is spaced out the way that it should be. So that is actually going to be really the meat and potatoes of this particular function. So, or this particular UIText quote-unquote object, if we want to call it that, structure, if you will. So obviously, we need to start with the create. The create is basically going to do a little bit of sanity checking, make sure we have a font name, make sure that we have text content. In other words, make sure we actually have a string, and make sure that we have an out text. And if not, we bleat about it and return. Next, we'll go ahead and zero out that memory just to make sure that we don't have any rubbish in there. We are going to assign the type first. So that is very important because the next step is acquiring the font from the font system. And if we don't have the type set, that is going to fail. So we've gone ahead and done that. Obviously, our font system acquire is going to do everything that we just wrote to go ahead and get that font. And then next, we are going to go ahead and we are going to set the text to the duplicated string of the text content, which means that this is a dynamically allocated string, which is fine. We are going to need dynamically allocated strings simply for the fact that you can always update the text and the length of that string can actually change or become longer. And so we don't want to limit that to a specific size because we can have strings that are thousands and thousands of characters potentially. Okay, so the next thing is we're going to go ahead and create a default transform for that the text transform. We're going to set the instance ID and render frame number both to invalid, and those will be synchronized once we actually have acquired instance resources and a renderer frame number. So the next thing that we're going to do is we are going to come in here and say the size of a quad is basically going to be 4 vertex 2Ds. And we're using vertex 2D because, again, this is UI. There's zero reason to have a 3-dimensional vertex here, especially for how things get rendered on the UI. So things in the UI will always be rendered in the order that they're actually drawn, which is the way that we want our UI to work anyway. Okay. So the next thing that we have is our text length. And for now, I'm going to use the string length. We may actually want to instead use, we may want to go ahead and use UTF-8 length on that instead, but I'm not 100% sure on that yet. So actually, I'm going to start off with the regular length, which will give us the length in bytes. And we only need that right now to say if the text length is less than 1, then we're going to set it to 1 so that we at least have space for a null terminator. All right, so the next thing that we're going to do is we are going to acquire the resources for the font texture map. So in this case, we are going to take a look at the shader, and we're going to say get the shader that's the built-in shader name UI. So that's going to be just our UI shader for right now. I have a to-do in here because we eventually may want to switch to a dedicated text shader. In fact, we're definitely going to want to do that at some point. Simply because we might wind up using sign distance fields for text rendering, which will give us a lot nicer font rendering, but down the road. So eventually we're going to want a separate shader for that, but for right now the UI shader will do just fine. We have a single texture map, so we've created an array of 1 essentially, and all we do here is we just say render shader acquire instance resources for these font maps. There's only 1, so we'll go ahead and do that. And then we go ahead and generate the vertex and index buffers. So this is all stuff we've seen before, so I'm not really going to touch on most of it. Only that the size of the vertex buffer is going to be the quad size times the text length, and the size of the index buffer is going to be the quad index size times the text length, which the quad index size is right here. So it's basically going to be the size of a U32 times 6. Okay. So the very next thing that we're going to do is we are going to call the font system verify atlas. And again, for a bitmap font, this is not really going to matter, but this will be super important for a system font. And we'll get into the reasons for that when we actually set up the system font. But basically we're saying verify that the atlas has all of the symbols that we need, or is capable of loading all the symbols that we need. That is going to be for the specific text content that we actually have for this particular object, right? And then we'll go ahead and generate the geometry for this text object by just calling our regenerate geometry, right? So we just pass our out text for that, and then we'll go ahead and return true. And that is the setup, right? So that's the, I should say the create. So we have a create. Obviously, that means we need a destroy. Destroy, I'm not going to go into too much depth on this because I think it's pretty self-explanatory, but we basically destroy the string, destroy the 2 render buffers, so the vertex buffer and the index buffer, and then release the shader resources and 0 out the memory. And that's it, right? There's nothing too groundbreaking with that. The UI text excuse me, getting over being sick. So the UI text set position is actually going to be really straightforward. All that does is call transform set position. Excuse me. And so that's basically just a pass through, right? The UI. Jeez. Sorry about the sneezing, guys. Anyway, the UI text set text is going to be pretty straightforward as well, at least on the surface. So we do some sanity checking to make sure that we have a text object and an actual string of text itself. We make sure that these strings are not already the same, because if they are, we don't actually want to update anything. And that is because the 2 strings themselves, if they differ, then that means we have to regenerate the geometry, verify the atlas to make sure that the atlas actually has all the characters that we need, and that's a lot of work. So an optimization here is just to say, hey, if these strings are equal, we don't need to do any of this, just boot out. So if they're not equal, then we go ahead and get the string length of the current text. We go ahead and free based off of that text length. And then we go ahead and set the text to string duplicate. So again, we use that string duplicate, which dynamically allocates memory for our new text. So we destroy the old, create a new. Verify the atlas, regenerate geometry. And that's basically all there is to that. So the draw is actually very simple too, because of the work that we have done in the render buffer. It allows us to keep a lot of that logic out of here. And so I put a to-do in here because we might have to use the UTF-8 length. I'm not 100% sure. We'll have to test that once we get to system fonts. But for right now, we're going to take the text length, and we're going to say we have the 4 vertices per quad, and we're going to use that to call our render buffer draw on our vertex buffer first, right? And if we look in here, we have an offset of 0. The element count is our text length, so the number of characters we have, times the quad vert count. And then bind only for our vertex buffer is going to be true because we have an index buffer. Likewise, when we come down here, our quad index count is going to be 6. So we use that when we draw the index buffer with an offset of 0, the text length times the quad index count. And then in this case, our last property, which is the bind only, is false because we actually do want a draw call on this. And of course, we make sure those things are successful, and if they're not, we boot out. But that's all there is to drawing these things, right? It's actually really dirt simple because of the work that we did in the render buffers, right? We keep all of that logic out of here and let this just deal with the things that it needs to deal with. Speaking of that, we now come to, as I said, the core of the UIText, which is going to be our regenerate geometry. This is actually where most of the logic for the entire file actually exists, because this is not particularly complicated, but there are a lot of instructions that have to actually happen to get the text to show up correctly. So the first thing that we're going to do is go here to go in here and get the UTF-8 length of the text. And I think that's the way that we're going to want to do this for geometry, which means we probably should do that up here too. I may have to fix that. And then we're also going to get the length in characters. So we're going to get both lengths, right? Because we're going to need both individually. And the next thing that we're going to do is we are actually going to calculate the buffer sizes for the index and the vertex buffer. And we're going to do that by basically doing our verts per quad, or indices per quad, and then multiplying those by the text length UTF-8, and then multiplying them by the size of a vertex 2D and the size of a U32 respectively. The next thing that we're going to do is we are going to potentially resize those buffers. So if the vertex buffer size, the new vertex buffer size, is greater than the existing vertex buffer total size, then we're going to go ahead and call our render buffer resize against the vertex buffer, and we're going to do the same check and call for the index buffer. So if we need to resize those things, we do that here. And now we're going to generate the geometry for each individual character. And this is sort of the fun part, right? So what we're going to do is we're going to keep a running X and Y in position. So as we are writing out the text, we're going to keep a running offset for the X-axis as we write from left to right. And then for any new lines that we find, we're going to bump that Y-axis and reset the X-axis. And so we need to keep those sort of running, those running totals, right? And then we're going to have some temporary arrays to hold the vertex and index data that we're going to be generating. And then we'll eventually load those into these buffers up here, and then we'll go ahead and get rid of those. So the first thing that we're going to do is, obviously, we're going to need to iterate every character. So we're going to take the length in characters, not the UTF-8 length, but we actually want to loop through the raw characters here. And we want to go ahead and get the code point for that character. And we're going to analyze, we're going to check for a couple things first, right? So we're going to first off check for a new line, right? So the escape sequence for a new line, or like when you hit enter on the keyboard or something like that, is \n. And so if the code point is \n, then we're going to reset the x value to 0, meaning that we're going to go all the way back over to the left side of the screen, and then we're going to increment the y by the text object's font data line height, and that will essentially bring us down to a new line. And then we're going to increment the UTF-8 character count, right? Because we're going to keep these counts sort of separately. So you'll note here our loop has C for characters and then UC for UTF-8 characters. And so we're going to track those things separately. All right, so the next thing that we're going to check for is we've covered new lines. Now we're going to cover tabs. So if we have a tab, then we are going to increment x by the tab x advance. So that's what that's actually going to be used for. And we're going to increment the Unicode character counter, and we're going to go ahead and continue to the next loop. Okay, so the next thing that we're going to do is we are going to go ahead and use our bytes to code point to go ahead and obtain the UTF-8 code point. So that way we actually have the proper code point for the next byte or series of bytes. And that's, of course, going to give us our advance. And then if, for some reason, this fails, like we don't actually have a valid code point, or we get a false for some reason, we're going to set the code point to -1, which is sort of our invalid symbol, which we can then treat separately. We can render question marks or something like that. So for now, we'll just go ahead and set that to -1. And then what we're going to do is we are going to go through our collection of glyphs in the text font data here. And we're going to loop through the glyphs and say, hey, if the glyph code point equals the code point that we currently have, then we can go ahead and keep a pointer to the address of the text data glyphs sub I, right? And then we'll break out of that loop. Now, one optimization we could probably do on this, and probably should do at some point, especially for large fonts, is we could probably make sure that the array is sorted by, the glyphs array, make sure that that's sorted by code point. It should be, I think by default it is, but we could verify that it is. And then we could probably just do a binary search, which would probably be a lot faster than just looping through this way. But for now, this is fine. We want to get it working first, and then we'll get it working fast later. Okay, so if for some reason we do not have a glyph, meaning we loop through all of the available glyphs and we just don't have one, then what we're going to do is set our code point to -1. And we're going to loop through again and say, let's grab the code point for that, right? And at that point, we should have something there for -1. And if we don't, I suppose we could put some additional logic in here, but I'm not going to do that for now. So at this point, we are going to assume that we found a glyph. And if we have not, we're going to throw an error about it and just say, you know what, we're unable to find this unknown code point, and we're going to skip, and we're going to increment and continue. Okay, so otherwise, we have found the glyph for the character that we're trying to render. And so what we need to do is we need to generate the points. And so what we're going to do is we're going to generate the minimum x, minimum y coordinates, and then the max x and max y coordinates to get a box. And so we're going to generate those here, which is our min x is our x coordinate that we've got our running x total, plus the g x offset, the glyph x offset. Y is going to be the same thing, just on the y-axis. And then the max of that is going to be the min x plus the width, and the max, or the max y is going to be the min y plus the glyph height. Okay, So the next thing that we need to do is we need to generate the texture coordinates, which is also a fairly simple calculation. So again, we're going to have mins and maxes. So we're going to have min x, max x, min y, max y. And basically the way that this is going to work is we're going to take the x of the glyph and divide it by the atlas size x, right? So we're going to get a, think of it as a sort of percentage across the bitmap. And that'll actually give us the x coordinate, texture coordinate. The y is going to be the same thing. So we're going to have the y divided by the height of the atlas. And then the max is going to be the x plus the width, right? So we're going to start on that, the right side of that box essentially. And then divide that by the width of the bitmap. And then the glyph's y position plus its height, in other words, will be at the bottom of that box. And then we'll divide that by the atlas height. The next thing that we're going to do is we actually need to flip the y-axis for system text. I'm putting this in here now because I know I'm absolutely going to forget it if I don't do it right now. And that's because of the way bitmaps are actually loaded in or generated for system text. So if it's a bitmap font, we're not actually going to do that. But if it's not a bitmap font, meaning it's a system font, then we actually have to flip that image because of the way it's actually loaded in. Okay, so the next thing we need to do is we need to generate our vertices. So our vertices, our vertex 2Ds, are basically the position and then the texture coordinate, and that's all we really have for that. So all we're doing here is building out our boxes, right? So we have 0, 1, 2, and 3, and this takes min x, min y, max x, min y, max x, max y, and min x, max y. And then we sort of do the same thing for our texture coordinates. And that gives us our 4 vertices that we're going to need to use. And then we're going to use our newly created points to fill out our vertex buffer data. So this is that array of vertices that we have created. And so we're basically going to index into that array based off our UTF-8 character count times 4, because we have 4 vertices per character. And then we have an offset of, this is the first one, so there's 0 offset on that one, second one, third one, fourth one, and then we have P 0, 2, 3, and 1, so that we achieve this layout visually. All right, and then the next thing is we are going to attempt to find kerning of this. And so basically what we're going to do is we're going to take a look at the next character and get its character code if it exists. So we get the offset of the next character. If there is no advance, move forward 1. Otherwise, advance as is. So what we're going to do is we're going to say the offset is going to be the character plus advance. And then if the offset is less than text length UTF-8 minus 1, meaning we're at the not at the end of the string, then we're going to get the next code point, right? So the next code point is 0, advanced next is 0. We're going to call our bytes to code point again, passing those in. We'll go ahead and get the code point for that. We'll get the kerning for the 2 code points. So this will be, if we loop right through here, through the kernings itself, we'll go ahead and take a pointer to that, check the kerning code point 0 against the code point, and the code point 1 against the next code point. And if both those things match, then we have the right kerning, and we'll go ahead and use that. And then, of course, if we don't find that, then the kerning never gets set, and the kerning is 0. So what we do here is we say x plus equals the glyph x advance plus kerning if we have one. And that is basically how we loop through and iterate through the text to generate our geometry. So now we have our vertices set up. We need to basically set up our index data. And so our index data is going to look something like this. We have 6 indices, obviously, per character. So we index at the UTF character offset times 6. And then we have plus 0, 1, 2, 3, 4, 5. And then we go ahead and we grab the character times 4. And then we we actually have a vertex offset of 2, 1, 0, 3, 0, 1, which is the order that the vertices, the 4 vertices that we generated up here, should be drawn in. So we go ahead and set up that vertex and index buffer data. And now we go ahead and we advance C, and we advance UC. So the C is basically plus equals advance minus 1. And I have a note here that we subtract 1 because the loop always increments once for a single byte anyway. So we need to subtract that from the advance that we got when we actually obtained the bytes to code point for the current character up here. Okay. So we have that. We have the UTF-8 character count that also gets incremented here at the end. And now that we are at the end of all of those, we've generated all of the vertices and the indices that we need. We are going to go ahead and load up the data. So that is as simple as calling render buffer load range for the vertex buffer size, the vertex buffer data, and then the same for the index buffer, passing its size and data as well. So we would have loaded those in, and then we can go ahead and free our temporary arrays for the vertex buffer and the index buffer data. We might wind up maybe caching these arrays to maybe use them more than once or something, or maybe creating a larger size and potentially wasting a bit of memory, but to not have to reallocate all the time. But for right now, this is the most flexible and quickest way to get it up and running. So the next thing that we're going to do is after we have done the free, we're going to verify the results to make sure that the load result for the vertex and index buffers was successful. And with all that, that is actually the regenerate geometry done. So that is the UIText. So we now have our font system, we now have our UIText. So the last piece is to basically hook all this up in the application so that we can actually use it. To do that, there are a few things that we're actually going to have to change. So let's see, how do I want to do this? I think the first thing I'm going to do is I'm actually going to change the render view for the UI. Actually, before I do that, there is one other render type I need to add. So render type INL. We'll go to mesh packet data. Okay. And we're going to go ahead and paste in. Since we have the mesh packet data, we're also going to have a UI packet data. So we're going to forward declare UI text here because we're just going to keep some pointers to those. The number of texts that we have, of course, this is very temporary, so I've got to-dos there. And then the mesh packet data, right? So this is basically for text objects. This is for non-text objects, which is our little Kohi logo up in the corner of the screen. So that's our UI packet data. And now we can go to render view UI.c, and we can make some modifications to this. So the first thing that we're going to need to do is at the top here in our include list, we are going to want to include UI text because we're going to handle the rendering of those in here. So far we've generated the geometry and we've loaded data into those buffers, but we haven't actually hooked up the rendering yet. So to do that, we're going to have to do a little bit of shader work in here, not with the actual shader itself, but to retrieve some properties of said shader. So the render view UI internal data, we're going to be adding a few fields to this. So first off, we're going to not only keep the shader ID, but a pointer to the shader itself. And then we're going to go ahead and hold the location of the diffuse map, the color, and then the model matrix. So we're going to hold the uniform locations of those things. And within our create method here, right after we get the ID, we're going to basically add the logic to store these things. So The shader is going to be the shader system get by ID, which we just obtained. Then we get the diffuse map location, which is diffuse texture, the diffuse color location, which is diffuse color, and then the model location, which is just the location of the model, right? So we go ahead and do that. And then down here, we have on our build packet, we need to make a couple of modifications here as well. So instead of the mesh packet data being used here, we are actually going to use, we're going to cast this to UI packet data, because it's not just going to be meshes anymore. It's going to contain meshes, but it's not going to be meshes on its own. So this obviously means that we're going to have to change some stuff on the application side as well to feed this in, but that is just fine. So one thing that we're going to do is temporarily, we're also going to set the out packet extended data to the data that comes in here, just so that we have that for the test objects. And then basically we need to change where we are iterating through this mesh data mesh counts. We need to change this mesh data arrow to packet data arrow mesh data dot mesh count. And this is going to be the same thing here. And then we are going to come down to our on render. And we have all this logic here for our render pass begin, applying our globals, drawing our geometries. So this is all good. But right after we finish drawing our geometries, but before we end the render pass, is where we actually are going to draw our bitmap text. So what we're going to do is have a loop where we draw all of the bitmap texts that are actually included. We're just going to do the packet data text count. We're going to use that as our iterator. So the first thing that we'll do is we will grab a pointer to that UIText sub I. We will go through here and bind the instance that is assigned to that text. And then we're going to go ahead and bind, or I'm sorry, we're going to go ahead and set the uniform by index. So we're going to set the diffuse map location. So we're going to set the uniform of that to use the address of our text data atlas. So that's where we're going to set the texture atlas to the diffuse map. And then we're going to go ahead and we're going to handle font color kind of halfway for now. So for right now, I'm just going to create a white color, which is all ones in a vector 4. And we're going to set that uniform to white color, right? So we're basically going to use the diffuse color and we're going to set it to white. Eventually, we are going to have a way to basically insert color codes into the string and be able to set different colors of text into the string. But for right now, we're not going to support that. And we're just going to render it just sort of as is. So the next thing that we'll need to do is we'll need to calculate a needs update, which is basically going to look at the text render frame number and compare that to the frame number that is passed in at the top here, right there. And if those don't match, then it's going to say, okay, well, we need an update. And then we'll apply the instance and say whether or not it needs an update. And then after we have done that, or potentially not done that, we will go ahead and sync the frame number so that if we happen to draw this again within the same frame using the same shader, we don't actually do that more than once. So the next thing is we have to apply the locals, which in this case is just the model matrix. And then finally, we can call UIText draw, which actually contains the draw calls for the UIText itself. And that is all there is in terms of actually getting this to render from the view. And that's my dog barking. I think there's somebody at the door, so I will be right back. Okay, and I'm back. So we have now basically got all of our stuff in place to be able to render the text. So now all we actually have left to do is to hook everything up in the application to get this stuff to actually load up and run. So we'll go into application, all the way to the top here in our includes, and we are going to include the font system right here along with all of our other systems. And in our temporary section, we are also going to include UIText because we are loading this here. This is not really where this should be loaded, right along with all the rest of this stuff. But, until we actually get to a point where we can configure this from the application side, this is what we have to do. So with that, we'll go down to this listing of states here because we actually need to add a state for the font system. So we'll add that there. And then we need to come down a little bit further into our application state. And right down here, right after the UI meshes, we are going to add a UI text. And we're going to call that test text. Real original name, I know. And then in application create, which is down here, we are going to probably go to after the geometry system. So we're going to go to right after the geometry system here. Okay, I'm back. Sorry about that. I suppose recording videos while I'm sick is not the highest item in the list of smart things I've done in my life, but regardless, so right below this geometry system is where we're going to put the initialization for our font system. And so in the interest of time, I'm just going to whack the whole thing in here in one shot and sort of explain it. So we have our font system configuration. So we're going to set auto release to false. This property really does nothing for right now. Again, that's probably going to be refactored. And then we have our default bitmap count is going to be 1. So we're only going to load 1 for right now. And these are just kind of the names of a couple fonts that I have up in here in our assets. So I have this Noto Sans 21 pixels. That's that huge one. And then I have this Ubuntu Mono 21 pixels, which is the smaller one. So I'm probably going to just do Ubuntu for now. And I'm going to provide, a name, a resource name, which is actually the name of this file here. The size is going to be 21. Again, that doesn't really even matter all that much, simply because bitmap fonts are always just one size. And then our array of bitmap font configs is just going to be this font config here. So we do that. Our default system font count is 0. The array is 0 because we don't have any of those things. And then the max system and bitmap font counts are 101 each. And I just wanted to go with a prime number there just for the sake of reducing the likelihood of collisions in the hash table. So anyway, so we call our font system initialize to get the memory requirement. We go ahead and allocate that memory. Same thing we've seen a bunch of times, that we go ahead and initialize the system and then bleat about it and return false if we fail. So that is that. Now if we go down here a little bit further, we have our sort of temporary to-do section here where we're just loading in all of our testing stuff. So we're just going to add to it for right now. And we're going to say we want to create our test UI text objects. So we're going to do a UI text create of the type bitmap. We're going to use the Ubuntu Mono 21 pixels. That's the name of the font that we're going to look up. And the size is 21. Again, doesn't really matter in this case. The text is going to be some test text 123, comma, space, new line, yo. Right, and so that's going to test a couple of things out to see if our new lines are working. And in fact, I'm going to also throw a new line and a tab in here just to see that those things actually work the way that we expect them to. And if that fails, we're just going to say we failed to load some basic UI bitmap text. Okay, so that is all there is in terms of actually loading the thing up. We do need to modify our packet a little bit. And so the way that we're going to do this is we're going to go down to our game loop, which we probably ought to separate this out into a function at some point instead of having it sort of in here. But I guess this is fine for now. Most of this stuff's going to come back out of here once we remove our temporary stuff anyway. So let's see, our UI section is here. So we're going to start by actually removing the UI mesh data because that is no longer what we're going to be passing in. We're going to replace it with the UI packet data of UI packet. Okay, and you know what? I think let me do one more thing. So I just had a thought that we didn't actually set a transform for our UI text, and we probably should do that, just so that when it actually loads up, we have a pretty easy to see position, so it's not like off the screen or something like that. So let me actually go back up to where we created that, and right below it, I'm going to set its position. We're going to do this, address of test text. All right, and that will set it to 5100 for that. All right, and then we'll come back down here to our sort of packet section and continue our work here. So what we're going to do is this UI mesh count and meshes, this is going to go away. And we are going to also technically get rid of this section here. We're actually going to replace this with a different function call. And so I'm actually just going to slam this whole thing in here all at once. So our UI packet is going to have the mesh data mesh count, which is going to be UI mesh count, and the UI packet mesh data meshes is UI meshes. So it's just sort of one level deeper now. We have a text count of 1. We've created a small array of text pointers here, and then we're going to set the first one of that to the address of app state test text, and then we're going to set the UI packet texts to texts. We're then going to say render view system build packet, the UI packet. We're going to pass through the UI packet as the actual data here. So we're going to pass the address of UI packet rather. And then the views 2, which is what we had before. Okay. So that is all we should need to do for that for right now. The next thing that we're going to need to do is after the loop completes, meaning we've exited the application, we are going to need to destroy our UI texts. And I actually had thought I'd move this up before, but apparently maybe I didn't. So let's actually do this and that. Okay. And so we release our cube map, and then we destroy our UI text. Okay. And then finally, we obviously need to shut our font system down so that we release any resources that is holding. And so we probably should do that in the opposite order of what we did before. So we instantiated it right after the geometry system, so we need to shut it down right before the geometry system, just to sort of keep that consistent. And I think that is actually everything we need to do to hook this up. So I'm going to clean and build. Hopefully I didn't miss anything, and let me run. Awesome, and it's a little hard to see until I move the camera, but we see here that we have some test text 1, 2, 3, comma, and then we've gone to a new line and tabbed over, and then we have yo. So it looks like all of our logic is actually working as we expected. So now we can actually display some text on the screen. Now, as a little bit of a bonus, I've mentioned that we can use this to help debug and problem solve. And so one of the very first things and one of the most useful things to be able to do, especially in a scene like this where you don't have a whole lot of context as to where you are in the scene, is to sort of echo out the camera's position, if you were. And doing that through the console is one way of doing it, but it kind of sucks. And so we're actually going to just add a little bit more code into our loop here to allow us to actually do that on every frame. So right before we actually create the UI packet, we're going to add some additional logic here. And basically what we're going to do is we are going to update the bitmap text with the camera position. So we're just going to use the default camera for now because we don't really have our full camera system with multi-camera set up just yet. So we're just going to use the camera system get default to obtain a pointer to the world camera. We're going to extract the position and the rotation from that world camera. And then what we're going to do is we're going to set up a string buffer that is 256 characters. That should be more than enough. And then we're going to call our string format against that, passing that, and we're going to say our camera position, and then within brackets, we are going to write out the X, Y, and Z for the position and the rotation up to 3 decimal positions out. So we're going to use the X, Y, Z of the position, and then we are actually going to take the Euler rotation of the camera, so the X, Y, and Z of that, and we're going to take the radians and convert them to degrees so that they're a little bit easier for us to intuitively understand on the screen. And so we're going to do that every frame. And of course, if the text itself doesn't actually change, we're not going to do anything under the scenes or under the hood. And so this is just a way to sort of to utilize that right away. So obviously that means that we need to call our UI text set text, passing in the text, of course, and the text buffer that we just went ahead and wrote to. And then we can go ahead and build our packet after that. And so this will actually provide us a little bit of utility that we didn't quite have before. So I'll build and run this. And now we can see that we have in rotation, our rotation works, right? We don't actually have a rotation Z, so we don't actually roll for this. But if we were to ever hook this up to be able to look at any object, for example, and we can get an Euler rotation or even a quaternion, we could display that there. And as I move around the scene, you can see that that is updating there as well. So if I load the rest of the scene just to kind of get a little bit of bearings here, we can say, okay, well, we know, this car is at least roughly, here in the scene, right? We can kind of go inside of it and say, okay, well, at least we know, roughly where the car is. Now, obviously, object selection and things like that will obviously improve the accuracy of that, but at least you can, move around the camera and get an idea of where stuff is in the screen and what the bounds of those things are, and where they are in relation to each other. So we can use this for all kinds of things. We're eventually going to use text heavily in the UI when we actually get to that, for all of our menus and all of our buttons and controls on the screen, and eventually an on-screen console, things like that. So there's definitely a lot coming. Anyway, that is about it for this one. So thank you guys so much for watching and putting up with my sneezing. Like I said, I'm getting over a cold, a pretty bad one actually. And so recording a video with that hasn't been the easiest, but thank you guys for putting up with it. And I appreciate you guys following along with this. If you haven't already, go ahead and like and subscribe. Those subscription numbers and likes actually really help me out. It helps drive these videos to be seen by more people so that more people can hopefully learn from the series. So anyways, thank you guys so much, and that's about it. I'll see you guys next time.